We have several people logging in, so I'll give 2 more minutes and we'll get started. All right. Good afternoon, everyone. Welcome to the Sigops How Georgia is Improving Traffic Signal Operations webinar. My name is Ayrton Coles, and I'll be your host today. In the name of the University of Tennessee, Center for Transportation Research, the Tennessee Transportation Assistance Program, TTAP, and the Traffic Signal Academy, I would like to thank you for your participation. This is our third webinar in 2021, and we are focusing on bringing you information on how technology and traffic signal data are being used by different agencies to improve traffic signal operations. We are looking at challenges, benefits, workforce needs, etc. You can find our previous webinars on the Tennessee Transportation Assistance Program channel on YouTube. I would like to thank Mr. Mike Clance, Engineer, Sales Manager, East, Urban Solutions, Q3 America, some of you know them by Intellite Controllers, for helping put this webinar together. Thank you very much, Mr. Clance. Thank you to our presenter, Kate Sharing at GDOT, and thank you, Mr. Lee Smith and Steve Bryan at TDOT for helping advertise this webinar. We are experiencing some storms here in the area. Hopefully that will not affect our webinar, but we have a plan B here. Matt Kate is with me. If we, for some reason, lose power, we'll have a plan B for us to keep going with the webinar, okay? Before I go to Kate's bio, just some housekeeping items first. Attendance. Please, if you have not done so yet, sign in your full name in the chat box. We really would like to appreciate everyone that has attended and that is attending this webinar this afternoon, even if you're not wanting to get a PDA certificate. Okay, so just please sign in on the chat box. Please avoid using your camera during the presentation, unmute your audio, or use the chat box to ask questions. Towards the end of the presentation, we will have some time for a Q&A. We'll be sending you your PDA certificate within the next 2 weeks, and that's going to be based on your chat box sign in and your registration info. Okay. You should have received actually several emails. We sent 2 emails this morning with information for you to download the presentation. And again, this webinar is being recorded. We'll post that on YouTube for you guys if you're not able to attend today. So our presenter today is Kate Sharon. She is a PE, PTOE, and Kate works for the Georgia Department of Transportation in the Office of Traffic Operations as the Metro Atlanta Signal Operations Engineer. Kate began her career in 2011 as an entry-level engineer at the department, reviewing and processing traffic signal permits until she moved into a position responsible for reviewing the project plans for traffic operations. In 2014, Kate joined the Traffic Signal Group as the Assistant State Signal Engineer responsible for managing 3 retiming contracts that cover the entire state and continue to serve as the office subject matter expert for traffic signal design review. In 2016, Kate was promoted to the State Signal Engineer, where she established 3 new regional traffic signal operations contracts to provide GDOT resources on a statewide level. In this role, she also managed several design contracts and the statewide traffic signal software upgrade deployment. At the end of 2019, Kate was shifted into the Metro Atlanta role in order to manage the current Regional Traffic Operations Program, RTOP, and oversee the creation of a new statewide traffic signal active management program to combine all of the current initiatives and create a singular cohesive statewide program which will be fully functional in 2021. Kate graduated from the Georgia Institute of Technology with a Bachelor's of Science and Master's of Science degree in Civil Engineering. She currently serves on the board of the Georgia section of ITE as the past president and is certified as a professional engineer in Georgia and a professional traffic operations engineer. Kate lives in Atlanta with her husband and 2-year-old son. So again, if you just logged in, please make sure that you sign your name on the chat box. And with that, Kate, I'm going to stop sharing. First, I'm going to stop my video. I'm going to stop sharing my screen, and I'll ask you to share yours.
Okay, can y'all see mine?
Yes, thank you.
Great. Welcome, and thanks for joining us today. I'm going to be talking through how we are doing traffic signal operations in Georgia and how that has evolved over the years. I'm covering a lot of information here, some at a pretty high level. So if you've got an area that you've got questions about or that you want more detail on, just let us know in the chat box because we do have time set aside for that at the end. So let's get started. In Georgia, we've got over 9,000 traffic signals, and there's more than 100 local jurisdictions that are involved in operating and maintaining these. This includes GDOT, counties, cities, and other local agencies. Each jurisdiction has varying levels of resources, varying experience, and different priorities for operating and maintaining the signals in their area. When it comes to GDOT traffic operations, we've got 7 district offices that have dedicated staff for traffic signals, including a signal crew. And then there's also a central office, which is where I work, which manages a lot of the larger contracts. And we've got some additional funding out of the central office. So we're going to start with a quick history of traffic signal operations in Georgia, and then we'll go into the new program, Sigops. GDOT has a really long history of supporting traffic signal operations and maintenance through a variety of different contracts and programs. 16 years ago, this approach was pretty disjointed. As needs and resources were identified, new contracts and programs were created. This resulted in a cluster of contracts that were difficult to manage and coordinate, both between the various contracts that we had, as well as efforts by local jurisdictions, because all of their stuff tended to be very separate. 5 years later, the concept of RTOP, a regional traffic operations program, had taken root in Georgia, which combined the management of multiple contracts under one umbrella and greatly improved the coordination and management of these elements. Rather than having different offices managing and requesting work under all of these separate contracts, RTOP provided consistency and reduced the overlap of efforts. A major focus of RTOP was to develop relationships with local agencies so that the resources and efforts from both sides could be complementary, and to break down the many regional boundaries that existed along a single corridor. Here's the initial iteration of RTOP. The program focused efforts on 10 regionally significant corridors, which included 396 intersections that crossed the multiple jurisdictional boundaries in the Metro Atlanta area. The operations teams were tasked with ensuring that infrastructure was maintained and to increase throughput on these routes. For anything that wasn't included on these routes, there were still separate retiming contracts active for improving operation. I'm sorry, y'all. By 2015, a second RTOP contract was added, and the number of intersections on this program had increased from the initial contract. Now we had over 1,100 intersections and 22 corridors were included in the program. In addition to the RTOP contracts and those corridors, several additional areas had been identified that needed more operational support. That's what you're seeing here in yellow. These were grid networks. One of them is in the Midtown area of Atlanta, one is downtown, and then the third one that's up on the north side is the North Perimeter area. There was a lot of traffic in these areas, a lot of signals that were close together, and the local jurisdictions needed some support because a lot of these signals were not on state routes. Separate contracts were set up with the maintaining agencies in these areas to share resources and focus efforts to achieve these goals. At this point, not much has changed for signals that were not included in the program, though. We still had statewide retiming contracts and some retiming contracts in the metro area that focused on any signal that was not included in this RTOP program. In 2018, there was a major shift occurring in RTOP. First, the separate contracts that were set up to help operate those grid networks in the downtown, midtown, and perimeter areas were absorbed into the larger program. This was mainly due to the complexity involved in setting up and managing these separate mini programs. Because we were sharing resources at that point, getting the contracts through procurement and defining the roles of everyone ended up being more of a hassle than it was worth. And since we had the ability to absorb it into the larger RTOP program, that's what we did. Another big change in RTOP was a shift from corridor management, which focused on that throughput, to zone management, which allowed operations teams to take into account overall delay in the area that they were managing. One of the complaints that we received a lot of times on RTOP, and you could tell that you were on an RTOP corridor, was because the side streets got punished. You were getting great throughput on that main corridor if you were on the route, but if you were trying to turn onto the route or navigating around an RTOP corridor, there were a lot of complaints about what was happening on the side streets. So in 2018 was when that massive shift happened, when the zone teams weren't just focused on what the metrics were along their corridor, but really what was happening in the whole area. You can see on the map, a lot of the corridors have side streets included and cross streets that went down a little bit further than just that main corridor. As the success of the RTOP program was recognized in the metro area, there was a desire to expand this in other areas of the state. A pilot program for active management in the Savannah area, which is in Region 3, was conducted under our statewide signal timing program. And that was what was the foundation for our new regional traffic signal operations contracts, RITSO. This divided the state into 3 regions and provided complete coverage for proactive traffic signal management. One of the main differences between RITSO and RTOP was that specific intersections were not defined in the RITSO contracts. RITSO had adopted a regional approach, which allowed GDOT's expanding resources to be deployed anywhere in that region, whether it was on a state route or not. Now, we did prioritize locations on a state route if our districts needed support on a main corridor and a local came to us that had just one intersection they needed help with. We would focus resources on the corridor first and then attack the smaller intersection. RITSO also expanded the resources that were dedicated to signal operations. We got some dedicated funding, we increased support for local jurisdictions and established a framework for this large-scale proactive traffic signal management. With all of these changes happening, GDOT released a revised concept of operations, which updated the program's mission, which is now to proactively manage and maintain traffic signals statewide by leveraging existing and emerging technology. The only way to achieve this on a statewide scale is to fully utilize all the technology that we have available now, and to continue to innovate for new methods to stretch our resources even further. We also released in that concept of operations new goals. This was to provide a safe and efficient and well-maintained statewide traffic signal system, to provide a flexible, accountable, scalable, and transparent traffic signal program, to promote collaboration and cooperation between statewide, regional, and local partners, to facilitate informed data-driven decision-making through technology, to efficiently manage and allocate financial and contract resources, and to provide a high level of customer satisfaction for traffic signal operations and maintenance. In 2020, GDOT announced the creation of a new statewide program to combine both RTOP and RITSO under one umbrella, and to convert RTOP into a fully regional structure as well. The rebranding to Sigops encompasses more than just the operations contracts that I went through the history on. Sigops also combines all the other traffic signal initiatives, including traffic signal performance metrics, maintenance, specifications, design, communications, signal upgrade program, and new initiatives to further our goal of innovation. So over the last 10 years, active management of traffic signals in Georgia has increased from 10 regionally significant corridors to statewide operations. I'll go into the operations contracts more in a few slides. The question you may be asking now is how. While it's helpful to know what has changed and how the program has grown, how is it possible to implement this type of program, and what do you really need to focus on? The framework for large-scale remote active management I've just described is only possible through the technology that we've deployed in Georgia and the partnerships that we've developed around the state. A major catalyst was the procurement of a new traffic signal software in 2015, Intellight's MaxTime. The main benefit of this procurement was the ability to collect high-resolution signal data. ATSTM is used to, and using that data to make decisions. Other benefits of this platform was that it was web-based, it allowed for additional timing options, was more user-friendly than our existing software, and it decreased the time to transition to different plans. The benefit of that was that we could have more plans because we weren't spending as much time transitioning. So if we needed a short plan to deal with a peak in an area, we could quickly transition into that, use that plan for a short time, and transition out of it. That was definitely a selling point when we were going around. GDOT not only procured this software to install at the traffic signals we maintain, but we did it for every signal in Georgia. We used a turnkey deployment contract where we would take the existing database, convert them to the new software, provide all the necessary equipment, including the upgraded CPU, get everything functioning as it was prior to the conversion, and then hand the signals back to the maintaining agency under the new software. This process also included training, both before we did the deployment as well as after, to deal with any issues that the maintaining agency had. We began this process of visiting all the maintaining agencies throughout the state to offer our services, with the bait of this new traffic signal software to get us in the door. I put together a whole menu of what was available beyond just the upgraded traffic signal software, including installing cellular routers in any traffic signal that wasn't communicating, access to traffic signal inventory site, assistance with maintenance and upgrades, and access to the resources in the operations contracts that we've talked about. A lot of these things we already had, but we hadn't been in front of a lot of the local agencies for them to be aware that these resources were out there. Sometimes these conversations were a little more difficult than I expected. There was a history between GDOT and local agencies from before I was with the department that was not always positive, and we had to overcome that. I made sure not to force anyone into participating in our programs or partnering with us. Basically, I put it as, here's what we've got. Whether you want to join us now or not, at least you know what we have to offer and how to contact us if you need anything. Through the statewide outreach, we did get a lot of positive feedback. Georgia now has over 7,000 intersections converted to this MaxTime software. In order to take advantage of all that high resolution data, GDOT has utilized the existing fiber network and deployed 4G routers to any other MaxTime converted signal in order to connect the data back to our statewide central traffic management software, which is MaxView. Currently, we've got over 6,700 signals on the GDOT network. The reason that number is lower than the 7,000 that have been converted is that some local agencies have their own server and they're communicating their signals back to their own server rather than ours. Through this communication, signal systems can be monitored and controlled remotely, and it allowed for the collection of high-resolution signal data to be used for performance monitoring and reporting. Some local jurisdictions have their standalone installations of MaxView servers that don't communicate currently with ours, but we plan to establish a connection to these remote servers in the future so that all of Georgia will be available under one to be viewed from one location. The central software has some additional benefits we marketed to the maintaining agencies, including that it was map-based, so you could easily find the signals you were looking for. Viewing the status of your entire network was all in one place, and you can instantly access individual signal information just by clicking on the signal. This centralized software was necessary for the remote monitoring of our traffic signals, especially on this larger scale, since operators don't have to go into each individual signal to review the status or data. Now, with all this data, we're not relying on citizen complaints or partners to let us know when there's an issue. We can use this data to determine what changes need to be made, as well as see that impact in the data once we've made those changes. Additionally, and this was a major selling point for locals also to convert, the system could send you an email to notify the right people when certain situations are occurring, like a signal and flash, or if phases were getting skipped. There was a lot of flexibility within the program to notify users about things that were happening. This extensive communication network that we created also allowed the opportunity to easily install CCTV cameras, especially at critical intersections, which allowed us to view live video feeds and enhance our ability to remotely monitor or adjust signal timing while observing immediate impacts on traffic. A lot of our staff, the consultant staff, as well as GDOT staff, are located in the metro area because Georgia that's just how most people are in Georgia. But Georgia's huge. We've got a lot of signals outside of the metro area. And in order to provide consistent operation across the state, it was great to be able to remotely monitor and see things that were going on, even if you couldn't drive out there and view it in person. Over the past few years, the Signal Group has prioritized installing cameras on arterials, and now we have eyes on over 1,000 intersections. We're continuing to expand that coverage over the next few years. One major change under the Sigops restructuring that we've done was to create a contract dedicated to maintaining and expanding our communication networks to the traffic signals. This has been a role that existed inside of our RTOP contracts, but we decided that this was so important of a role that it warranted a separate contract, specifically one that wasn't tied to one of our regions, so that we would have consistent staff for the whole state. And we would have dedicated funding to ensure that we had consistency across the whole program in the state. The contract will include managing the fiber and 4G networks, troubleshooting communication network problems, and coordinating with GDOT IT for communications architecture improvement. We have seen a huge benefit of sustaining this liaison role between our group and GDOT IT to translate and coordinate goals and requirements between our two groups. I don't speak IT. A lot of people that I work with do not, and GDOT IT does not speak signals. So having someone that kind of knows both sides of that and can translate what we need so that we can get what we want done has really helped us. So let's get back to the operations contracts, and it's all that data and infrastructure we just deployed. Under the restructuring, the Metro Atlanta area has been divided into 3 new regions to create a total of 6 regions statewide. Each of the 6 regions will be supported by a separate consultant contract and dedicated funding. The regions were selected based on an attempt to balance the number of intersections as well as reduce the points of contact we had. And what I mean by that is that statewide regional boundaries followed GDOT district lines, and the Metro Atlanta area regions were defined by local jurisdictional boundaries with the intent to streamline the communication between local jurisdictions and the resources that GDOT is providing. One of the things that I found really frustrating when I took my current role was that some jurisdictions had signals that were covered by the RTOP 1 contract, others in the RTOP 2, And then the rest of their signals were under the RITSO contract. That was the regional contract at the time. So not only did they have to know which signals were under which program, but they also had to know who was the point of contact for each of those contracts. These new regional boundaries will fix that. Each jurisdiction will be within one contract. The 3 statewide regions are already under contract as RITSO contracts, and the 3 metro regions will be in place this year. Our shift to a regional approach means that all signals, at least those that are communicating with our server, will be remotely monitored on an automated basis. In order to prioritize operational needs and resources, we will need to utilize a tiered approach to define the level of remote monitoring and field presence required for each intersection. Critical and bottleneck intersections are going to require a higher level of monitoring and field presence than other locations, which may only require monitoring or resources under certain situations, whether that be planned or unplanned events. Events like the Super Bowl provide context that can temporarily or permanently shift a signal's level of importance within the program, but this approach will allow us to focus resources where we need them most at a specific time. The role of the operations contracts in Sigops include automated and remote monitoring of traffic signals, maintaining and improving existing timing plans, implementing innovative timing concepts, responding to alarms and complaints, developing new timing plans, monitoring and modifying traffic signal timing during events, identifying and troubleshooting malfunctioning equipment to pass on to our maintenance programs, coordinating with local jurisdictions and GDOT, making recommendations for construction projects, and meeting annual ground preventative maintenance goals. We're able to accomplish all this with a mix of remote and field staff operation engineers, signal technicians, data analysts, and maintenance inspectors. The success of our previous programs and the future of Sigops is dependent on the relationships and trust that we have built with all the cities, counties, CIDs, and the district signal groups, who now work directly with these contracts on a daily basis. A goal of the restructuring was to simplify the organization for our stakeholders so that they were better able to understand the scope of this program and how they can utilize the available resources and collaborate with the program to achieve their own goals. Let's look at all the tools that we have established to support these efforts in these contracts, which most of our stakeholders are also able to utilize. With the mass deployment of MaxTime, GDOT adopted the automated traffic signal performance measures, ATSPM software. ATSPM shows real-time and historic functionality at individual signalized intersections. Since there was a previous webinar on this, I'm not going to go into a lot of detail here. These performance measures allow the user to remotely find more issues with equipment, as well as identifying and investigating operational concerns, which then saves field time for technicians and engineers. All of the intersections communicating with GDOT network are configured in ATSPM. One more thing on this. This is a public-facing website. Anyone can access this, whether they're in the industry or not, or if you just want to go to it and see what we've got. I've got the link there at the bottom, so you can go in there and see what we have put in there. GDOT also has access to RITIS, Regional Integrated Transportation Information System data. RITIS uses probe data to provide real-time speeds, comparative and historical speeds, and current and average congestion. Additionally, RITIS provides a view of overall traffic signal system performance and reports bottlenecks, user delay costs, and data on special events. The use of this data was a shift from physical infrastructure coverage, which meant that GDOT was no longer limited by equipment placement in order or the need to maintain that equipment. GDOT currently tracks traffic signal inventory with a program called Teams, which is a traffic engineering asset management software. GDOT uses this application to track traffic signal equipment in great detail, which includes signs, ADA compliance, overall rating of intersections, obviously the traffic signal equipment, projects associated with intersections, preventative maintenance records, and tasks that GDOT has identified as important. If we get a complaint, we'll put a task in there that says that we're dealing with the complaint and what was done. If equipment goes down, that gets logged as well, including the date that it was resolved. The information that's collected in this database is essential to tracking equipment needs and the status of unresolved tasks. Prior to the deployment of the upgraded traffic signal software and approaching maintaining agencies, we had used some of the existing consultant contracts that we had to populate the inventory data for the state route signals statewide. An asset management site is only useful if it's accurately maintained. By providing a populated database, it made it easier to get buy-in for using the system. Again, our intent was not to force anyone to use these platforms, but to provide them with the opportunity for it. Some agencies have utilized this across the state and others have not. From a GDOT perspective, we did get a lot better buy-in from our district offices having previously populated it so that we weren't handing them something that they then had to do a lot of work in order to get up to speed on. Since it was so important for us to track all this information for our GDOT signals, for the districts that were unable or unwilling to update the system, we've used our consultant contract resources through the operations contracts to maintain this information. Through one of our existing regional contracts, a SharePoint site was developed to create a dashboard for both the operations teams and the stakeholders in the area to track contract resources and activities in their region. The dashboard also pulls information from RIDIS and integrates with that team's asset management site to give operations groups more insight about the area that they're managing. This SharePoint site was so successful that we've expanded the dashboard to include all the rest of the regions. So each of our regional contracts has access to this dashboard as well for their area. The most utilized tool that GDOT has developed is the Sigops Metrics. It was initially launched back in 2018 to track signal performance measures for reporting. It was also initially named Mark 1. If you've ever heard us talk about that before, we've renamed it under the rebranding that we've done for Sigops. These metrics included throughput, arrivals on green, queue spillback rates, split failures, and travel times. Since the initial launch, the deployment or development has continued on this site to provide more information to the operations teams about the status and progress of their efforts. So it's been a shift from a reporting site to more of a daily activities site for some of the metrics. It also tracks volumes by corridor, equipment uptime, including CCTVs and vehicles and pedestrian detection, and teams tasks. Users can observe trends on a programmatic level by different jurisdictions or on an individual corridor level. Sigops obtains and processes data, or Sigops Metrics obtains and processes data from ATSPM, RIDIS, Teams, and our Navigator site, which is our ATMS platform. Automatic reporting and the dashboard of information make this an indispensable tool in our program. Because of everything that has been added to this site over the years, we are currently in the process of reskinning and reorganizing the site to better meet the needs of our users. This site is open source. I recently learned that Maricopa County in Arizona is in the process of implementing the site for their arterial performance measures dashboard as well. This year, we released a new concept we have been working on, a health metrics score. This is inside of our Sigops Metrics site. I don't believe it's entirely live yet, but I'll give you kind of a preview of it. The need we identified was that we have to compare signals across the state to be able to distribute resources effectively. With all the data we have coming in, how do we do this through a prioritized system to ensure that we're not missing anything big in all this data? To do this, we've come up with a scoring system that takes into account data from operations, maintenance, and safety. Each intersection is assigned a context, which puts different weights on some of the metrics. For example, pedestrian delay may be a high priority in a downtown area, but not so much at an isolated intersection. So we have 5 different contexts that get selected for each intersection so that the weight of these metrics is applied appropriately. These summarized data points will help the operations teams manage their region by identifying issues. making timing adjustments and coordinating the upgrades. So our operations metric includes a platoon ratio, pedestrian delay, split failure, travel time index, and a buffer index. Our maintenance metric is a mix of detection uptime, pedestrian detection uptime, communications uptime, CCTV uptime, number of flash incidents. And then our safety metric is a crash rate index, a CABCO crash severity index, high-speed index, and pedestrian injury exposure index. And once this all is completely live on our system, we've got documentation about the data behind each of these performance measures, as well as the calculations that are going into them. This is just one example of how we've continued to innovate with the data we have available to better support the Sigops program. And another new statewide contract under the restructuring is a contract to support system maintenance and development. GDOT has prioritized and continued development of the supporting systems we use in order to accommodate new innovative data analysis methods as they arise in new tracking recommendations from our teams. Since all of these systems are utilized on a statewide level, we wanted to separate this one out as well from our regional-based contracts. This contract will also include some staff that will be monitoring the state for incidents and coordinating with our TMC 511 staff to provide consistent feedback to all our regional operations teams about the incidents that could impact traffic flow in their area. This is an aspect, this staffing is something that we have currently under the RTOP contracts, and it coordinates this type of information with the metro operations teams. Under the new contracts, this role will be expanded to statewide. The operators will monitor the camera feeds, news outlets, social media, and other sources to quickly identify incidents and notify the appropriate operations teams so that adjustments can be made to accommodate the changes to traffic. The intent here is to provide a group that is seeing impacts for the entire state, that higher level picture, rather than just relying on the regional teams who are focused on their areas. So this contract covers that staffing aspect, as well as the continued improvement of our Sigops Metrics sites, any additions to ATSPM. I've got some examples of some of that we've done, development on our SharePoint site, and any upgrades that we need to these systems that support our Sigops operations teams in the future, which may include swapping out some of the software or just improving it. Separate from our operations group is the GDOT traffic signal maintenance group, which is responsible for maintaining the traffic signal specifications, the traffic signal QPL, the warehouse contract that we buy equipment from, and overseeing our on-call maintenance contracts. To fully optimize our traffic signal networks, functional infrastructure is required. These two elements work hand in hand to achieve our goals. The reason these are two separate groups is to provide focus on the importance of maintenance and to ensure consistency across the state. For GDOT, this traffic signal maintenance group is a fairly new role that we created as the scale of our program grew. Maintenance sometimes got put on the back burner to operations. So we really felt that we needed a team that was focused on it. So we created a role that was over the maintenance and provided consistency for all the staff that was working on these operations teams. But our operations teams work very closely with the maintenance group to identify and prioritize needs for their area and help develop the paperwork necessary to get this work completed. GDOT has established multiple mechanisms to achieve maintenance goal, which include a robust and flexible on-call traffic signal maintenance contract, multiple contracts, and coordinating with maintaining and agencies on available resources. Our on-call maintenance contracts utilize the technique where contractors submit prices when establishing the contract for specific tasks on specific timelines and for specific areas in the state. So if they only want to work in the northern region, they will only provide costs for the different line items in that area. With this setup, we're better able to predict what can be achieved with our budget, and we're able to both respond quickly to high priority equipment malfunctions, as well as complete significant upgrade work all under one contract. The only limitation of our maintenance program is that we must work within the existing footprint and right of way. We cannot buy right of way. If we want to buy right away, we've got to kick it over to our signal upgrade program, which does a full plan development and project that goes through the letting process. It's just a normal project. GDOT works closely with local jurisdictions to coordinate resources. Sometimes we're able to provide equipment to the local jurisdiction or GDOT signal crews to install or agreeing to complete work under our on-call maintenance contract if the equipment is provided by the maintaining agency. So this coordination allows us to stretch our resources further. Either we can provide the equipment and they can install it, or they provide the equipment and we install it, or sometimes we do both. But that way we're working with the maintaining agency on achieving their goals as well as ours, while not just relying on our resources. There have been a lot of changes in the last decade in Georgia for active traffic signal management. The most notable is probably the scale. In the first RTOP contract, there's 396 intersections along 10 corridors and were identified. And in the last round of RTOP contracts, we had over 1,700 intersections in the metro area that fell under this program. Now under the statewide Sigops program, the entire state is eligible for GDOT resources to monitor and manage the signal operations. We've currently got over 8,000 intersections supported by this program. In order to manage such a large program, GDOT has divided the state up into the 6 regions, and we will have those 2 statewide contracts to support communications as well as the software that GDOT utilizes for this program. Over the past decade, we've gone from 1 contract to 8 just for operations. Back in 2011, RTOP started with dedicated funding of $8 million. GDOT has supported the expansion of this program with additional dedicated funding that's now around about $30 million per year just for operations. Additional funding sources exist for maintenance and signal upgrades. The approach and vision of this program has also significantly changed over the years. We've gone from that corridor-based model, which focused on increasing travel throughput on those corridors, sometimes meant negatively affecting the side streets, to a regional-based model, which takes into account all of the different goals of stakeholders and proactively manages traffic signals to balance the negative impacts that may occur in the area. The monitoring has also changed significantly from mostly field monitoring and directing teams to be present on their corridor. So now we rely a lot more on central and remote monitoring, which has been necessary during COVID. This is also necessary to both cover the number of intersections that we are now including in the program, as well as to have consistent quality engineers working statewide. Technology improvements have been essential to being able to scale up and transition to a central and remote monitoring approach. 10 years ago, none of the signals communicated back to GDOT, none collected high resolution data, and GDOT did not have the arterial CCTV coverage that we have now. Now we've got 6,700 intersections communicating back to our central server, and we've deployed over 1,000 arterial traffic monitoring cameras. The upgrade to traffic signal controllers, which collects that high resolution data, has now been deployed at over 7,000 intersections. And a final major change that has been how performance is evaluated, which has moved away from travel runs to utilizing ATSPM data, made possible by that high resolution data coming back to our central server. But while a lot has changed, there's still a lot of aspects that have remained throughout the iterations of this program. The driving force behind the creation of RTOP was to improve communication and collaboration between GDOT and the local jurisdictions to improve outcomes. These partnerships with locals having that open line of communication is key. While I have focused on the technical aspects of these contracts and what they can achieve, the success of this program is really continuing the connections between all the people in Georgia who are trying to improve the operations on our arterials in order to make everything work together. GDOT has used this program to create the connections and tie everything together in order to work towards a larger goal where the operations teams are the liaisons. We've accomplished this by establishing memorandums of understanding, those MOUs, with local jurisdictions. These help us define where the locals want our support and where our contract limitations are. Sigops does not replace maintaining agencies in any way or their resources, but we provide access to additional resources and support to supplement where they may have gaps in order to achieve goals for both GDOT and the locals. By leveraging the maintenance money, we strengthen that partnership by ensuring that the locals are keeping our teams in the loop about their maintenance needs. This helps us with finding issues with certain devices and tracking life cycle information. If the local has staff to install equipment but does not have the funding to purchase it, we can reduce the burden on our funds, as well as keeping their crews working. A big benefit that we've seen with many local agencies is supporting planned and unplanned events, whether that's an annual event in their area or an unexpected road closure due to a crash. Bringing in additional resources to handle these events can be difficult for them. Since our operations teams have experience with managing events, they're able to step in and support the locals where they need it with planning, creating new timing plans, as well as managing traffic throughout the actual event. Not only is collaboration with locals important, but internally as well, we need that collaboration to exist. Operating traffic signals is a daily role and continues no matter what is going on. Creating relationships with the staff managing those construction projects that are ongoing keeps our teams in the loop about the status of the projects to better manage the traffic throughout the construction and to have a point of contact if there are any issues. If they already know us before there's a problem, they're more likely to respond when we do have a problem and get that issue corrected. We provide benefit to the construction offices as well by providing experts to recommend approving work in areas that they may not be very familiar with. A lot of the construction teams that are overseeing projects don't necessarily have experience in fiber installation. So we can provide someone that knows what that should look like and how to set it up and how to splice in appropriately. And we can make a recommendation back to the project team on whether or not the work is done correctly. Other GDOT programs like the safety program and operational improvement program, as well as large capital projects, also obviously impact signals quite often. Being aware of the work that is being planned through these large scale projects help us determine where we should hold off maintenance work. If we know that a roadway project is going to come in and widen the road, we don't want to install new mast arms that would be torn out and replaced in a year. So we may hold off on maintenance work that we could have done otherwise. This is also an area where locals can tell us what their programs and funds are doing by having that communication with them as well. So if they're going to do a resurfacing project or an intersection improvement project, we're not doing maintenance work in that area right before they come in with a big project. My final point on the importance of collaboration is coordination between all of our regional contracts. There's a lot of flexibility in these contracts to allow for innovation. And I don't know what happens in your area, but I found a lot of consultants don't particularly like to talk to other consultants and share what they're doing. We've set up what we call crosstalk meetings with all the consultant teams on our operations contracts in order to set up this knowledge share about what's happening in their region, what is working and what is not working, so that the program as a whole can benefit. If you've got the same issue that was solved in one region that's now occurring in another, and we've already figured out how to fix it, now we've got people coordinating together. The SharePoint chart I showed you is one of the tools that came from one of our regional teams that was presented at one of these crosstalk meetings, and our other teams were like, that is really awesome. We would like that in our area. And that's what got us to expand it for statewide use. Making room for innovation is another key point to success. RTOP was a prime location to test out new technology over the past decade, specifically because we had a large number of staff on the program, which provided a massive amount of oversight and consistent review of this technology. Not only do we test new physical products on corridors, but RTOP has had resources set aside to develop new ideas, like how to utilize additional data sets and integrate that information into the function of the operations team. The biggest innovation has been the development of that Sigops Metrics site, which we continue to improve. Additionally, the RTOP contract was used to develop a new ATSPM metric that evaluates the gaps available for left turning vehicles. I've got a little picture of this, that left turn gap analysis in the bottom of this slide. This metric has been added to the GDOT ATSPM platform, so it's available for use for anyone. What this does is give you a better idea of whether or not a permissive left turning vehicle has a gap available to do that, to turn permissively safely. And what we've used this information for is setting up protected permissive by time of day. If the gaps are reduced during the peak hour to a point where you're not getting enough vehicles through permissively, and we're seeing a crash history in this area, we can use this data to back up that gaps don't exist during that time. So people are probably taking gaps that are not safe for them to be taking. And we can restrict doing that permissive phase during the peak hour and only do protected. We're also working on another metric for determining wait time at isolated intersections. This was another thing that came out of our crosstalk meetings. We've got a lot of rural intersections on the statewide level that we didn't in the metro area. And this wait time metric allows us to see delay on all approaches rather than just on the main line. So that's another thing that we are working on that we hope to get out here pretty soon. Flexibility is the next pillar of success that I want to talk to you all about. You have to be flexible with how these types of programs will grow and change because of how many moving parts there are. Technology is changing so fast that it's impossible to project what everything will look like a few years down the line. As you can see, the Georgia program has changed significantly just in 10 years. Who knows what it's going to look like another 10 years from now? I don't think anyone could have predicted a decade ago what technology would be available right now. We're constantly looking at the program to find where there are bottlenecks in our processes to figure out new ways to approach that situation and evolve the program to the next step. The operations contracts specifically have a huge amount of flexibility built into them because we don't know what's going to happen on our roadways on a day-to-day basis. Today, we may have several crashes that reroute a huge amount of traffic that we need to manage and react to, or we could just be an average day where we can optimize signal timing plans and identify maintenance needs. There's always work to be done, but we don't know how much of it's going to be a priority, if we're going to need additional staff on that day. And having that flexibility built into the contracts allows us to do that. Within these contracts, we require a few specific roles like a project manager and team leads in certain areas, really to make sure that the group has the knowledge necessary to do this work. But how each team wants to manage their staff and organize them in order to manage the signals assigned in their region, we've really left up to them, because the consultants are aware of what the strengths and capabilities of their team members are, and they can best assign the work accordingly. A great example of that is that some of our technicians have been trained or cross-trained in some signal timing aspects, so that if they're out in the field and they see something weird is going on, they can go ahead and make a timing change. They may have an internal structure that they need to notify certain people about what they're doing in order to communicate what is happening out in the field. But if they've got someone that has knowledge that crosses over several roles, we want the teams to be able to utilize that and not just keep someone in the technician role. This cross training has really helped our program develop the workforce. There's a lot of movement, especially in Georgia recently, of people shifting roles. So we want to make sure that we keep as many people in Georgia as possible and they don't get bored. When it comes to local jurisdictions, each one is going to have different gaps and needs. Some have full staff and a TCC to operate their traffic signals. We've got others that use the local power company to maintain their signals. There's no one size fit all approach to supporting these locals. From region to region, it's very different. From jurisdiction to jurisdiction, it's very different. So we need that flexibility in the contract in order to be able to deal with that as well. And finally, be flexible with restructuring the staff internally. GDOT's internal staff has grown as the program has grown. When I joined the Signal group, I think there were less than 10 people, and now we're at 25, somewhere around there. We've invented new roles to focus on areas that were not getting the attention that was needed to be successful. And we've shifted around staff to do workforce development. The roles of our staff have evolved along with the program. And I think that has been key to making sure that we can manage all of the contracts that are coming out of this program as well. When it comes to a program like this, the best thing you can do is just get started. Don't try to plan for every situation. Figure out what your current needs are, build flexibility into your plan, and be prepared to make modifications for the next iteration based off of what has worked and how things have changed. And that is all I have for y'all.
All right, Kate. Thank you so much. This is awesome. Fantastic. Great job, Georgia. This shines a light on what Tennessee and other states can do as well. So this is very, very good. We have some questions coming in, and I'll start with Mr. Clint Jones, and he's talking about something that is close to my heart also, because I'm working on a traffic signal inventory here for the state of Tennessee. So it's related to that Teams software. He wants to know, is the Teams software part of another software package, or is it a standalone software? Has it been developed in-house, or can you tell us a little bit more about that?
Yeah, absolutely. Teams is a separate software that was procured under our top contract. I think Applied Information Inc. Is the developer. It's completely separate. We have not developed anything on it. It's not GDOT specific. I think the idea came from my supervisor, Alan Davis, who used to work in South Carolina, and they also utilized the program of Teams. And so that's how it kind of made its way over to us.
All right. Can you just, one more thing before we go to the next question, regarding the inventory?
Yeah.
Yesterday we talked a little bit about that. Can you just tell us how hard it was for you, for your team to get this information from some of the agencies?
To actually populate our asset site?
You mentioned you use consultants, right? But did the agencies have any roles on this?
So we used a signal retiming contract on the statewide level to send consultant staff out to each intersection on state routes. We only did it for state routes, and fill out all the inventory information so that we could pre-populate teams, at least for all the GDOT signals. Local jurisdictions, some of them have bought into this and are utilizing the program. Any intersection that was not already included from that deployment we did with all the consultants, either they had to populate, or some of them did request our assistance with getting that information populated. And we used our consultant resources. Since we didn't get a whole lot of local jurisdictions that wanted that information populated in our asset management site, we were able to accommodate the requests that did come in.
All right, thank you. Next question is from Jorge Riveros. I think he's from Nashville. How did you navigate the procurement requirements and working with so many different IT departments? In my experience, these two particular issues have always been the breaking point for more regional integration of systems. This and the anti-CIP interoperability preferences of differing systems between agencies, example, hardware, firmware, and software. So I guess a little bit, if you can elaborate on procurement requirements.
So there's a couple different aspects to this question, and George, if I don't answer it, let us know in the chat. The way we did this was because we used our software. So we weren't using different systems between agencies. We upgraded all of their hardware to the same CPU with the same Intellite software on it, and it was tying back into our system if we were providing operational support. So the different IT departments that we do deal with local agencies is more of creating a connection from their servers to our servers, mostly to our ATMS platform so that they can see cameras. And that is something that our communications group does deal with. That's a little over my head in terms of how they actually make those connections. But the procurement part of it, so the software procurement was done separately. That's what allowed us to upgrade the traffic signal software across the entire state. That was a GDOT procurement. It was all GDOT funds. Local jurisdictions didn't have to have anything to do with it except for telling us that they wanted to convert. We came in with consultant staff under our contracts, swapped out the CPU or any other equipment that was necessary in order to make their signal function with the new software, and then we handed it back to them. So their procurement did not get involved at all in that.
Okay, all right. Next question from Jibo Senior from Oak Ridge National Lab. Could you please share a little bit more about what you're doing regionally in moving away from optimizing flow along localized arterials? So how you're approaching your regional, I guess, optimization instead of just looking at a specific arterial?
Sure. So we're working very closely with the local agencies to make sure that their needs are met. They know what corridors the most people are coming in on, where they've got the most complaints, where they feel like there needs to be improvement in the signal timing. So rather than just our teams focusing on the metric of throughput or what was happening along their major corridor, we're using delay metrics a lot more for seeing what's happening on the side streets in order to balance any negative impacts that are going to go on in an area due to overcapacity. And especially in the metro area, we are dealing with a lot of areas that are way over capacity. So rather than punishing the side streets to get that metric on the main line to be so great, we're using the mainline metric as well as the side street metrics to make sure we're not causing problems elsewhere just by trying to get an improvement on the main line. Did that answer your question?
Yeah, I think so. We have also a similar question from Lydia Benda, and I think you already mentioned this with your answer here, but she said, you mentioned changing the measurements from throughputs on the corridors to zone measurements. So it's similar to Jibo's question.
So we're still using throughput. That's still a metric that is in our ATSPM site. Let's see if I can pull that up for y'all. I'm gonna lose seeing the questions again.
Yeah, and just to finalize that question, what are the metrics you use to measure impacts in a zone? So you mentioned delay on the side street. And
okay, can y'all see my slides again?
Yeah.
So this is our Sigops Metrics site. As you can see, we still have throughput, but now we're also looking at arrivals on green, progression ratio, spillback. Split failures is a big one that we look at now. And these travel time and planning time index are definitely corridor based. But the previous iterations of our top really focused on throughput. It was just about improving throughput each time they reported on it. And that was how the program itself was rated, were they improving throughput each time on these corridors? And at some point, especially after 10 years, there's only so much throughput that can happen. You're not going to continuously be able to get more and more vehicles through, especially without causing major issues elsewhere. So over the years, we've been shifting to adding in these additional performance metrics So it's not just about throughput. While that's something that we still want to ensure is consistent, especially where we've optimized signals already, or that we're improving in signals that we haven't optimized yet. We also want to make sure these other metrics make sense as well, for the context of the intersection, that peak and off-peak split failures are not high, no matter what the intersection is or what the corridor priority is.
Yeah, makes sense, definitely. Before we move to the next question, I'll just go back to the performance metrics. Lydia is also asking about if you include metrics to measure transit movements. Do you have transit signal priority incorporated in the system? How about emergency vehicle priority? So I guess the question is, I've seen before some ATSPMs where you actually can measure the amount of time the signal is transitioning or in preemption. So do you do anything related to transit and to preemption?
So our group is not specifically responsible for transit priority. GDOT has taken the stance that we want to work with local agencies that want to implement transit signal priority or emergency vehicle priority, but GDOT itself is not doing that. We've provided some guidance to our locals about how to engage with the software with whatever system that they want to use, but we're not tracking performance of that system at this time. We do have, MARTA is doing a lot of transit signal priority planning right now, where they'll be implementing that soon. MARTA is our Metro Atlanta area transit authority.
Yeah.
So we don't currently track that kind of information. I would think down the line that maybe something, especially in areas where we get a lot of it, like the Metro Atlanta area, that we may incorporate into our Sigops Metrics sites. But since we don't have a lot of it out there now, it's mostly on the local jurisdictions to monitor and assess the performance of that.
Okay, all right, thank you. Let me go to the next question here, Mr. McLanahan. And this one, I have one on it as well. So you have a slide there that mentioned your shift from 8 million to 30 million in about a decade of funding. And that is just for operations, correct?
Correct.
Yes. So the question is, where does the funding for your organization come from? Is it STP, congestion mitigation, or what type of funding?
We have an annual element funding out of the GDOT budget that comes to the signal group. We've got a couple of different pots so we've got one pot for the Metro Atlanta area that's partially federal funded, partially state funded. Then we've got a lump sum budget that does our signal upgrade program, as well as the statewide region contracts, the RITSO contracts that we currently have. And then we've got state funds from House Bill 170, which is the very large funding bill that happened in Georgia a few years ago that gives GDOT a large amount of money that funds our maintenance program as well. I don't know the exact funding sources though, but STP and congestion MIT don't sound familiar. So I'm not applying for these funds each year. They come out of our GDOT budget.
Okay, so I guess what I'm seeing here is that 10 years ago, 15 years ago, someone saw the importance of investing in signals and,
yes,
and putting money to maintenance, putting money to operations, and it has grown to the point where we are now.
I think one thing specifically that happened in GDOT that I'd say is probably just lucky for the operations group is that we had several people from operations move into upper management.
Okay.
We had several commissioners that came from upper management, or commissioners that came from operation, as well as the deputy commissioners and our chief engineer. So the people that were up there were already aware of the importance of operations, and they've given us a lot of support.
Yes, makes sense. So Ted Bacon from Cleveland here in Tennessee, are you using Intellite controllers exclusively? Do you use the MaxView software to globally push out firmware updates?
So we are not using Intellite controllers exclusively. It would be expensive for us to replace every controller in Georgia when we did that deployment. We did swap out all the CPUs for Intellite CPUs, but they do work in some other controllers. And we do use MaxTime software to push out firmware updates. That was also a big selling point of this, was that you didn't have to go to the intersection to upgrade the software, that we could push out an upgrade. And that's helped a lot when we have so many signals.
All right, awesome. So Andrew from, I believe, West Virginia here, what control strategies are you using beyond coordination? For example, are you using adaptive, traffic responsive? How has the Sigops system facilitated the identification of candidate corridors for these strategies, or the specific strategy to be deployed?
That is a great question. And we have a huge toolbox of strategies that we can use in Georgia. A lot of that does come out of having this Intellite MaxTime software. We do use traffic responsive. Sometimes it gets used a little more often than necessary, I think. But it has been a push under the RTOP program over the past few years to implement it everywhere. I don't know that that's necessary to do everywhere, but we do have a lot of traffic responsive set up. We do not use a lot of adaptive, although there are a couple of local jurisdictions that invested in some adaptive software that they continue to use. They did not want to convert over to our software. In terms of identifying corridors for these different strategies, it's mostly been a conversation with the local agencies, as well as recommendations from our operations teams who are responsible for the signals in that region. If the basic strategies that we have aren't working, let's try something else. We use a lot of user logic under MaxTime to do some very unique programming within the signal, such as if we've got a lot of pedestrians at an intersection, we can try using an LPI, a leading pedestrian interval, where we're getting the pedestrians out before the traffic gets a chance to move. That way they're more visible to any turning vehicles. If we've had greater concerns with pedestrians, we've used some user logic to turn off turning phases, or even to turn on a no turn sign, not a changeable message sign, but
blank out.
Yeah, a blank out sign when the pedestrian phase is activated. So it's really a case by case based off of what we're seeing and what the data is showing. There's no one size fit all thing, especially when we're looking at some signals that are out in the middle of nowhere and aren't coordinated with anything compared to a signal in downtown Atlanta.
Yeah. And again, you're doing that through control logic, like if then else statement.
Yep.
All right, cool. I don't see any specific questions on the chat box. I have a few more if you're okay with that.
Yeah, that's fine.
What I always ask our presenters is regarding staff. Okay, I know you already mentioned that. I think you mentioned from 8 to 25 people now.
Mm-hmm.
But I'm interested in if you can elaborate on how ATS-PMs have been incorporated into your workflow. So staff involved with analyzing data coming in, monitoring. So what I'm saying is, do you have like a period of the day in the morning that for 2 hours you look at the data from yesterday and you act on it, or how do you do it?
So since this program has grown so quickly and we've increased staff so quickly, a lot of the focus on our younger staff has been on just managing all of the consultant teams that are responsible for the ATS-PM data. So our consultants are the ones that are more engaged with the ATS-PM data, because they're more of the front line of working with the actual signals and making the changes to those signals. But our staff is trained on this information and reviews a lot of reports that come out of our consultant teams, and we're getting them more involved with the day-to-day operations and making sure that they're comfortable with that. But it is taking longer than I probably would have liked to get them up to speed so that they feel more comfortable with using this data. So no, we do not have 2 hours available in the morning to review ATS-PM data every day. We rely more on our consultant teams to be doing that effort.
Makes sense, makes sense. All right, one of your slides, and this may be a question if Mr. Mike Lance wants to join here. You mentioned that the interlight controllers or the Q-free type of controllers there, they have quicker transition times between plans, right? So what are we talking about? Less than a cycle, or what have you noticed that has got your attention about the quicker transition times?
Mike, do you want to jump in here? Or you want me to?
With Mike, you just may need to unmute yourself. Feel free to join me. If not, you can just go ahead, Kate.
Okay. Mike, if you want to hop on, I can stop talking. Previously, we were seeing somewhere more around 10 to 15 minutes to transition from the software that we had previously, which obviously causes a lot of problems. If you don't transition before the peak comes in, then you're now in this transition phase where things really aren't coordinated well, and then you cause a lot of extra traffic during that that time of trying to get into step. What we were seeing under the Intolite was more like a couple minutes to 5 minutes max, just a couple of cycles to get into step with everything. So we're able to shift in and out of certain plans a lot faster without wasting that time of being out of step and messing up traffic as much.
Yeah, great. And Mr. Mike Clance just mentioned that we lost the audio here, but yeah, everyone on the call here, great tip from Kate here. I always try to teach that on my classes also. If you know that your peak period is starting at 10, start to change your timing plans at 9:45. Don't wait to 10 o'clock, because then it's going to take 10, 15 minutes or even 5 minutes to get that into coordination again. I'll go with one more question, and then we have some more coming in here. So you mentioned also, I think I saw in one of your slides that you're collecting at least, or you're using SPAT data. Do you have any DSRC? Are you thinking about 5G, or what are you talking about when you mentioned SPAT data?
So GDOT does have a connected vehicle deployment. We started that on RTOP because RTOP is our test bed for new equipment. We've been doing that for the last 3 years, although it's been paused while there's that issue with the spectrum going through. We are starting to deploy them again. They are DSRC as far as I'm aware right now. I'm not sure if we are shifting. I'm not over that area. I think right now we've got 200 locations with connected vehicle technology deployed currently. The stance that GDOT is taking is that we are going to be putting up the infrastructure for it and broadcasting the data, but we are not interpreting the data. We're leaving that up to vehicles and app developers to actually interpret that data for users to ingest.
Yeah, okay. We have one more question here from Andrew, and I think you touched a little bit after I asked you one of the questions, but do you track usage of your ATSPM website? Do you have a feel for how many people are using it on a regular basis? For example, repeat visitors, who they work for, GDOT, consultant, local, and why they are using it?
I've seen some Google Analytics on the ATSPM website just to kind of see what kind of traffic we're getting on that site. It's not something we review on a regular basis. Like I said, that with some of our other softwares, it's pulling in information from this ATSPM site. So like our Sigops Metrics site is pulling a lot of information in from ATSPM. So people may be getting that information through one of our other platforms. So I don't know that getting traffic on ATSPM specifically will give the whole picture of how people are using this data. While we're going through this reskinning process for our Sigops Metrics site, we are looking at a lot of the Google Analytics on it and getting survey feedback about how people are using it and what aspects they're using it, so that we know how to restructure and reorganize the new look of the site so that people don't have to click over 8 different tabs just to get the information they want if they're using it all in every day.
Yeah, makes sense. Ted Bacon, and we have just two more questions here, and then we are running out of time. So Ted, again, you mentioned permissive turn movements by time of day. I was not familiar with that ATSPM performance measure, so that's great that you guys helped develop that. Do you use a specific formula to determine those times? So I guess all we're looking for here, if you can elaborate a little bit more on that permissive turn movements by time of day.
Absolutely. So we are in the process right now, GDOT is in the process right now of developing an operations guide that kind of talks about how we use or how we operate traffic signals in Georgia, just to document it. And one of the things that's in there is a lot about left turn movements and the policies, well, the guidance behind when we put in a left turn phase and using protected permissive versus protected only or permissive only. And one of the things that we do talk about in there is protected permissive by time of day. Because when you're looking at an intersection, if there's not a sight distance issue, if there's not a documented safety issue, there's really no need, or another geometric issue, there's no need to do protected only at all times of day. Because if you're coming up in the middle of the night when there really isn't a lot of traffic, and there's no reason why you couldn't turn permissively. So why would we restrict that and keep people sitting at a light when they don't need to? So kind of our most recommended treatment of an intersection is going to be that protected permissive. But there are going to be certain times of day that permissive operation is just not recommended, whether that be because there's not enough gaps in the opposing through movement, or it could be a situation where, and this is actually one that I've come across, where the sun is coming up and at a certain time of year and during a certain time of day, you just cannot see this recommended sight distance in order to make a determination of if there's a good gap available. And so we may restrict permissive times during that. But in terms of a specific formula for that, it's mostly based off of engineering judgment. Okay. So we're not using the left turn gap analysis to trigger doing protected permissive, because it could be a situation where typically there is not a permissive or a gap for a permissive turning vehicle, but people aren't trying to turn permissively anyway. So it's not really harming it to have that option up there if people aren't using it and there's no safety issue with them having that option, just in case there is a gap that is available and they do decide that they can turn safely. But if there are other factors like a crash history, or they're getting complaints, or they've just observed near misses and they don't feel comfortable as the engineer that's over that intersection, all of those factors are going to be used together along with this data from this left turn metric that tell us that we want to restrict permissive operation by time of day. And we document those in an engineering study that goes into a folder about the intersection so that we can reference it later if we need to.
And the flashing yellow arrow has made that possible as well.
Yes.
Related to that question, do you guys have dual left turns with flashing yellow arrows?
We do not currently.
Okay.
That's not something that we've really dived into. I have seen a couple of plans where we have dual rights with permissive, with an FYA, but no, not for dual lefts. That's one currently automatically kicks it to protected only.
All right, so to finish us off here, how about if you spend just a few minutes talking about how important was this program, either the RTOP, or I guess at the time it was the RTOP. A few years ago, you have that issue with the collapse of the bridge deck in Atlanta, right?
Yep.
So how did that process of rerouting traffic work? How important was having the capability to have all this information, to have all these connected signals help with that situation?
So when that happened, I wasn't over RTOP, I was over the statewide group at the time, but I did hear a whole lot about it because we're in the same office. having this program and the consultants already in place who knew the area and who knew the routes and who were engaged with the local jurisdictions, it was vital. It was the only reason that it worked. They were able to get out detour plans within, I think it was within 24 hours that they had detour plans set up. And they were developing new plans around the area. A lot of our signals were not communicating at that time. So we were still getting communications up everywhere. So that's something that we got out immediately because it was something we were doing on a statewide level. So we had the routers already purchased and waiting to be deployed. So we got those out immediately. And because of these contracts, we had the staff to get out there and do that, and to have people monitoring signals around that whole area. I think that's the only reason that it went as well as it did. And that engagement with all of these people was necessary. Same thing with the Super Bowl. This program is why the Super Bowl traffic operations went so well, because we have the available resources to do something like that. When we've already got them under contract, we've just shifted them around so that they were more focused on this area at the time, because that's where the priority was.
All right. So Kate, thank you very much. This was great. The presentation and of course the Q&A session here. I thank you very much for your participation.
Oh, my pleasure.
And those of you that are still with us, please make sure that you sign back or sign out, I guess, on the chat box. And again, Mr. Mike Lentz, thank you very much for helping put this together, and Kate as well. So I'll talk to you. We're planning another webinar probably for April or May. So I'll let you guys know the topic as soon as I can. Thank you very much for participating. Please sign out on the chat box. And again, Kate, thank you very much for presenting.